this video, I'll walk you through my home assistant, an AI-powered smart home project which I built using React, Home Assistant, LangChain, Python, Docker, and Ollama. I'll explain the architecture, demonstrate the key feature, and show how the AI agent controls smart home devices using natural language. The project also includes live weather, face detection, security automation, and modern React dashboard. And also, I'll be showing you the security bug which I'll be having in this project, which I'll be fixing this in the future upcoming video. By the end of this video, you'll have a clear understanding how this project works, which helps you to build your own project. And this project not only focus on the building an agent for Home Assistant, but also the security on top of that. Let's jump into this video. Hello everyone, welcome to my channel Cyber with Kraaj. In today's video, I'm going to show you how I built my Home Assistant AI-powered smart home dashboard. So this is the overall project overview. So in this project, I have a agent, I have web app, and I have a open source Home Assistant app, and I built a virtual home where you can see living room, bedroom, kitchen, hallway, and there's a garage also so that I can track or the usage of the devices. So all these devices, right, which I am controlling through the Home Assistant, and Home Assistant have an API, and through API I'm trying to control the device. Okay, so in this video, I'll be controlling the device, which is virtually okay. There is no actual device, it's all virtually device. Like there is a TV object which I am turning true or false, which is on or off. Similarly, light switch, which is on or off. So it's like just a true or false value. It's all are virtual. There is no actual devices. But in future, I'll be connecting to actual hardware to see how this works. So here required tools are Docker desktop, which I'll be orchestrating all the flows. Node.js. So why I'm using Node.js, right? I have a web app which I can control through the web app to control these devices, virtual devices, through React Power, which is Vite framework, and I'll be using Python, which is on top of that I'll be using LangChain and MLflow to monitor the token usage and to monitor the performance also. Uh, then I'll be using Ollama. So I am using Ollama is I have a local GPU 5090, which has 32 VRAM, which I can power very large language model. But as this is a smart home assistant, I need a less GPU power, which mean I'll be running very small model in my local. So let's say if you have a VRAM which is less than which is 8 GB, it should be good enough because in future I'll be using this agent running in some Raspberry Pi or Jetson, NVIDIA Jetson. So I'll be training the model and I'll be deploying the model in those devices, and I'll be connecting to actual hardware in the future. But for now, I'm running this in my local. But if you think you don't have money to buy a GPU, what you can use any cloud or a large frontier model, a cloud model, which is GPT or Gemini or NVIDIA or any cloud frontier model, right? You can use them. And I'm using Chrome for face detector, which I'm using a security camera, if you see in the picture, right? Which is PC camera, which I used to record the video and display in the web page. Yeah, in future I'll be using face scanning to unlock the door. So this is a quick start guide where I'll be running this Docker Compose, right? I'll be running all this setup, the Docker, using Docker Compose up-d, and I'll be using the .env where I'll be storing some secrets, because in order to access the Home Assistant, right? I need API key, right? I'll be generating API key for this Home Assistant open source app, and we'll be using this API key to access those virtual devices. And yeah, then I'll be using Ollama. As I mentioned, I'll be running this in my local, right? So I'm using Qwen 3.5, which is 10 GB VRAM, I believe. There's a one more model called, let me show you, Ollama list. So there's one more model called Qwen 2.5 VL 7 billion parameter. So this is very small model which can sit in I mean fit into a small GPU, which mean I can run this in the 5060 graphics card or any graphics card. And if I want to design a actual virtual home assistant, the actual physical device, right, IoT device, which I'll be building in the future using Raspberry or Jetson. So I'll be using this model, so that this model I'll be deploying into those devices, and I can have these devices to communicate to Home Assistant app. I can run this going individually. Further, I can run each and everything, but it's Docker Compose. I already have the script ready, right? Where to go, how to go, and everything, so that I don't want to run the command manually, so that it can run in virtually on the Linux container, and it can start running, so that I can deploy in anywhere, right? I can deploy in different computer, and I can also deploy it in the any cloud services, which is easily be transferable, right? Okay, let me go back here. Oh, sorry. Let me close everything. Okay, here you go. So this is the overall system architect, and as I mentioned, right, I am controlling this Home Assistant through two channel. One is through agent, right? Uh, this agent currently I am trying to communicate through chat as an interface, and the browser app is like I'll be seeing some screen, web screen, where I'll be clicking the button as you shown over here. I'll be clicking the mouse button here, right? So that I can try to control the device by clicking the button, start device, unlock the door, right? Switch on the camera, and turn on, turn off light by clicking the mouse over this picture. I can show you that in the upcoming video. So I have a two channel, right? As a user through web, I can control this. Through the chat agent, I can control. So yeah. Okay. So yeah, so these are the APIs. So the Home Assist have this APIs, right? Which I'm trying to access this API through front-end web browsing and through the chat. Okay. So yeah, and this is very simple, right? So I have three component. One is like agent and web browser, and I have a virtual Home Assistant app, right? Okay. Yeah, these are the overview, right? So this dashboard I have this virtual devices, and these are the device reference done through the vibe coding using Claude. So anything can be done. So all I'm trying to explain you the concept of how you can build this Home Assistant app, right, or any app in your home, right? No need to buy any expensive fancy product. So this is something you can able to do it in your home and try to learn by yourself. Okay, now let me jump into the project. So this is a Docker Compose file. These are the service as you seen in the README file. So these are the service I'm running. So Home Assistant is the I'm just pulling from the Docker image and running it, and I just loading the configuration like a living room. Maybe I have lights, TV. I think all those devices, virtual devices, are configured in this config file. Let me go to the config file, and under HA config, this is a Home Assistant config, and yeah, this is a YAML file. And if you see, right, instead of maximizing this, right, let me go to the outline. So it will just read the YAML file, and it used to parse it so that it's easy for me to show you like what all the parameter I'm passing over here. So if you see right, this is the main thing. So here you see right, input the boolean. As I mentioned right, it will be true or false. So it's all boolean value, right? Sprinkler. I have a two sprinkler also, a front camera, so kitchen dishwasher and everything. So it's like virtually built. And if you see and the input number, so this is numbers, I want to save it in because I'm running the thermostat, right? So I need to decrease the temperature, so I can't be this can't be a boolean value, it should be some numbers, right? So so minimum is 60 and the maximum is 85. I can pass this value through web API or through web app, right, to set this temperature in between this value, or I can ask the AI agent to set this value. So yeah. And again, EV charge level, again, I have some, as you see in the previous diagram, I was showing you the battery level, which is 0 to 100. So you can change these numbers here. And yeah, okay. This is a Postgres database which I'll be using for the backup for the Home Assistant where all the device will be stored. And MLflow is a proxy, I can say. It's between the agent and able to monitor the or the context, what context I'm sending from the front end to the agent. It monitors and it can able to show me like what is the token in, token out, right? And also I can future I can use as a AI gateway also because the MLflow it supports the gateway flow too. And this also the MLflow also I'm pulling from the Docker image. Then agent, like this is a agent. I just coded this agent using Python. I'm just building and loading to the Docker image, which is inbuilt Docker image. This is, and the web app is something like hosted with the React, right? And if you see, right, I'm passing the HA token, which is the Home Assistant app token, which I generated from the Home Assistant UI. Maybe in future I'll be showing you how to generate a token and how you can able to use them through the API through front-end React web app. When this .env file is loaded from this env, and this env has the few config file, and also this also have the Home Assistant API key, which I'll be accessing through the agent. Okay, if I want to uh, talk to the agent to stop any IoT device, right, or the smart devices, virtually connected devices, right? I can able to use from this through this agent. Yeah, these are the component and volumes is something like all this configuration file I need to save, right? It needs some storage which I'll be using under this volume. So Postgres data and the ML4 artifact, right? All will be storing under this volume. So again, everything was built through the cloud through vibe coding. So just I'm just want to build a home assistant virtually and want to connect to all this component, and I need to control this home assistant, right, through the API, through agent and through web app. Okay, let me run this Docker image now. So this is a Docker Compose file which I have all the services. So normally I'll be using this VS Code shortcut to control this Docker services. You can type a command Docker Compose and you can try to pass some parameters to start the service. But for now, like to make life easy, I just right click and do Docker Compose. So it try to pull all the images and it start to build. I already pulled the images, so it's very fast. Right. For this demo, I was trying to show you guys how to start the services. So I just started the service here. You see, right? The service up and running. And I have IAM also, my AI agent. So this is some different project, but this is my IAM is something like I'm running some single sign-on service which is called key clock, which I'll be using in this home assistant. Because if you see, right, this home assistant has a vulnerability, right? This is open to the network, all the chat assistant, the UI and the API key which I am hard coding. You should be able to see that API key in the network trace, right? I can show you because it's not vaulted, right? So I'll be showing using a vaulted solution also in the future. So, and there is no rate limiting which I'll be setting because if you expose this API, sorry, there's a UI or the chat assistant to the outside world, there will be a lot of attacks, right? So anyway, this my home assistant is something like running within my local network, so no need any type of and exposing this UI outside world. But in case if you want to do, you need to have a WAF and everything in place. So again, in future I may be doing that so that I can control these devices from anywhere in the world, right? So yeah, maybe in the future I will to add them. And yeah, these are the fix I'll be doing in coming lessons. But for now, like I'll be trying to access this UI. Let me open the Chrome and okay, let me go back to this Docker instance and let me go to the Home Assistant. Oops, sorry. Yeah, so these are the services running, and main thing I need to use a web app AI. So I'll be using AI because the agent will be running inside this web app, not inside the. I expose the AI agent interface through this web app. So if I try to open this, here you see, right? Currently, three devices are on, and I see the cameras also on. Let me disable it, and yeah. So let me turn off all the services, right? Yeah, this is a simple UI interface. So what I'm doing is I'm trying to pull the live weather forecast, which is open source again. So I'm just using that API to pull the live weather, right? Based on the weather, it try to change the background so that I know like what is my condition outside my home, right? Then if you see, right, there is a EV charging garage, and yeah, there's a front end door which is lock. I can lock, unlock, and here's a dishwasher I can start, stop, and this is a living room which I have a TV which I can turn off, and there's a temperature which I can able to control through this mouse, right? And yeah, there's a lights on off, right? Here you see some background, you see some blurred yellow, which is the lights is on, and if I click on again, its light will be off. Okay, and you see sprinkler, I can click it, it will be turn on. Yep, it's turn on, and yeah. So this is something, everything again, which will I can show you if you see the network trace, right? If I turn on the TV, so here you see it's a API call which I'm making to the 813 port, which I'm running 813. You see, right? Home Assistant, which I'm Docker image, which I'm running the container, right? So this is the service I'm trying to access, right? And yeah, it's making API call, and if you see the payload, all I see using is the entry ID and the payload which I'm pasting turn on. Okay, so if I want to turn off, and again in the parameters saying turn off on the payload parameters passing, which is the item which I'm trying to turn off, right? So yeah, again dishwasher also same off on, right? So I can turn off. And yeah, let me show you like chat. So this is the again through web app, but if I try to type, right, it goes through the AI agent. It talks to this agent, and this agent is embedded with the LLM, right? Let me show you quickly. Ollama, Ollama list. Yep, these are the LLM I'm running in my local, and if you see env, this is a secret, and the secret is something I generated. It's anyway, the secret is something like only accessed from internal, right? So it can't be accessed from internal. So just showing you like this is a token I'm passing it for the web app and as well as Home Assistant, right? And if you see the agent, okay, I think I need to go to the .env file of this. If you see, right, I'm using Quen 3.5 and Quen 3.5. Yep, this is the one I'm using this. And if you see my GPU, and if you the GPU before I start the service, So currently GPU, I see some spike, which means some traffic coming through. Let me check it's coming through the some LLM service, or how can I check? Okay. Let me go back here. I haven't started the chat agent yet, right? Let me ask hi, okay? And let me switch to the GPU. You should see some spike over here. 5 GB VRAM, now it's consumed to 12 GB, which mean it loaded. So if you see the actual model size is 6.6 GB, so it loaded to my VRAM, right, GPU, and it's now started to use. And here you see it's replied, and if you see it's saying like how can I help you today, and it's giving me all those options which I can try to type here, right, instead of clicking the button and doing all the stuff. I can ask agent assistant to do that. Let me check like, can you switch on lights in kitchen? Okay, so yep. Can you turn on the security? So I just created a ML workflow, which means it will turn on the security, means so it will enable all the security system. So it switch on the camera, it's monitoring currently like any suspicious activity or something like that. You can able to record it, right? So and let me do this. So let me disable this and let me unlock the door. And I'm asking, okay, turn on the security system. Now you see it locks the door, and also it switch on the camera, it's monitoring now, right? So yeah, so I created the workflow for this so that any security related, right, I can able to control over all the devices, any have a high visibility, like especially this door lock, right, people can enter, right? So I just want to make sure this have a proper security control. In future I'm planning to use one more model in front of this door which can read my face, and it can able to unlock the door. So I'll be showing the demo in my next lecture, and it's very pretty cool. And again, so yeah, these are the home assistant, and you can able to control everything through this chat. And also I enable the voice, but here I'm not using any related like voice LLM here. All it what is doing, like it using the built-in Chrome voice to text, sorry, voice to text speech. If I enable it, here you see, right, Chrome is trying to enable it, allow this time. Can you turn on the dishwasher? And if you see, right, type the sentence and it gave me, and just I want to click the send button. Yep, dishwasher is on. All right, and let me show you the YAML, which is pretty cool. This is also a open standard, I believe, and yep. And if I go to the home, here you see it created a uh, some configuration for home assistant agent, and all you see the LLM, and you see what is the latency. I can able to measure the performance of this AI. And if I go back to the trace, I can see like what all the prompt or what all the context I gave, and how much token it consumed, right, and how much the latency. So based on this I can improve my performance using, like, let's say I can fine tune this model so that it can improve, I can improve the latency. But anyway, like these are all like natural language, right? So I don't want to do any type of an fine tuning. But in future, let's say if I want to be speed up this process, right, I can load some more than let's say this is this is 6.6, right? If I go somewhat further, maybe 6 GB, because the more size, the more processing power it needs. Less size, which means the model is trained with the less parameters, so which will be more faster. So I can reduce the size, and I can try to evaluate the latency, so that the instantly the way I speak or way I type and click send, or click send button, right, in this case the latency will be improving. So yeah, and let me go to uh, one of the tracking ID, one of the requests, right, came through. So here you see, this is an input message, and it's saying like it's a human, which is the user prompt, right? And what I'm saying, can you turn on the dishwasher? And that request is passed to the Ollama. So in Ollama, this is a system prompt, right? And it's sending along with the user prompt, and it's sending to the Ollama API, right? And Ollama API can able to recognize, okay, I need to use this function start dishwasher, because then I can able to sense like user want to start some dishwashing services. So let me call this function, and this function is nothing but the tool function, right? Now in this tool, it passing the parameter like the uh, it passing the start dishwasher parameter, so it knows, okay, I need to start the dishwasher. And voila, and it responding by meaning that the dishwasher started, and voila, getting the response dishwasher started, and responding me, okay, the kitchen dishwasher is now running, let me know if you need any assistance. So yeah, you can track all this prompt and everything, and I can put some guardrail also. Let's say if I'm using some wrong language or something, I can block it here also, right? Yeah. Uh, so these are the quick demo I want to show you. Thanks for watching. See you in the next video.